Okay, welcome back to the fourth lesson. This is going to be an interesting one because in this one we are going to learn what exactly are tokens. At the same time, we are going to learn how exactly these LLM models work and how are they trained. So this is a very interesting topic actually. So first, let's start by understanding how do LLMs actually even work. If I take any simple sentence, let's take something from here itself. This is a very simple sentence, right? Artificial intelligence is transforming industries. It's a very simple sentence. The way LLMs actually work is, I'll try to take a different example. Hi, how are? I've written these three words. Now what I'll do is, this is my LLM model. I'll take this hi, how are, LLM. The output is going to be you. It's going to predict the word. It's going to give you as the output. Now what I'll do is, I'll take the same thing. I'll combine the U here. This should be small actually. The prediction is going to be question mark. Now I'll add this question mark again, and there's nothing to predict here. Now it will say uh, EOS, I believe. Uh, I, let's call it end token. So usually different companies will have a certain thing for end token. You can uh, use any string as your end token, like EOS, EOD, etc., etc. So once it predicts the end token, that is where the API will understand that, okay, there is nothing else left to predict, and this is the final output. It will take all of this and it will give it back to the user. But essentially what we are doing is we are predicting the next word. It's always the same thing, right? I'm taking hi, how are, and I'm getting the third word. I'm taking all of them together, I'm getting the next word. Similarly, if I'm using this sentence, first I'll get artificial. Next, I'll get this one. I'll pass artificial, and then it will give me intelligence as the output. Next, I'll pass both of them as the input. I'll get ease as the output. Now I'll take all three of these. I'll take ease and for me. This is the output. So this is exactly what's going on behind the scenes, okay? So every time the LLM is simply predicting the next token. That's all it is doing. So here, every word here is a token. So artificial is a token. Artificial is a token. Intelligence is a token. Ease is a token. Transforming is a token. So these are four different tokens in the backend. So it is basically predicting the next token. Don't assume token to be a word because the token can be let's use this one actually. Transform can be one token, ing can be one more token, and space is also a token. So in the actual predictions, this is how it will look like. artificial space, intelligence space, is space transform ing. ing is a different token. So they're all different tokens. So it doesn't, so token doesn't mean a word, okay? So token can be a part of a word as well. So how exactly are we creating these tokens? How do we know where to break it? So this is where the model training comes into the picture. So if you take a look at this piece of code, I'll simply copy this one. Let's go into VS Code. I'll paste it here. Okay, let's see what we are doing. We are using GPT-2 tokenizer from transformers. So I'm using something called auto tokenizer and I'm passing GPT-2 here. This is a very old version of GPT, so don't expect this to be accurate. But essentially, this is where it all began. So I'm taking a very simple string here. Artificial intelligence is transforming industries. The same thing again. I'm saying tokenizer.tokenize of this text. So my tokenizer is going to tokenize, and these are my tokens, and I'm getting my token IDs. Let's print it to see how it looks like. So if you see, art is one token, official is one more token, the space is being converted into this G and with a matra, the dot at the very top. This is space. Intelligence is one token. Sorry, space intelligence is being considered as one token. Space is as one more token. Space transforming as one more token. Space industries as one more token, and the dot as a separate token. Let's add a new line here, or yeah, new line. It is very interesting. It is very interesting. I'll put this. Now let's see what comes up. So here you can see for the new line characters, it is using the C. It's a totally different symbol. So for spaces, it is using this symbol. For next line, it is using this symbol. For tab, it will use a different symbol altogether. You can see this is a totally different symbol again. And space it, space is, space very, space interesting. These are all the different tokens. For each token, this is token ID, but you can ignore this part. But essentially, you are getting the different tokens from your particular sentence. So that was everything about tokens. It's essential to learn and understand these tokens because we are going to refer to these tokens n number of times when we are working with any AI model. Uh, so the token creation, we call it a token, we call it as tokenization. So the tokenization is the very first step. Or actually, it's just one of the steps. There are n number of steps before the tokenization also. After tokenizing, we use something called as embeddings. So embeddings are a vector representation of these tokens. It's very important to understand what are these embeddings, how are they created. We don't have to know the exact details of it, but we need to have at least theoretical understanding of what are these embeddings. Okay, let's take any one of this. Okay, artificial. Oops. Artificial is a word, and the tokens for this particular word are going to look something like this. They are just huge array, not just one array, but there will be n number of arrays. All of them are inside of one more single array. So this is what you call as an embedding. So if you see this, it has 1, 2, 3, 4. This is a 3 by 4 matrix. 3 by 4 matrix, which is extremely small, but usually these embeddings that they actually use in the LLM models, they are in huge size, somewhere about 1,000. I'm just taking a rough estimation here, 1,000 by 1,000. So which means you can imagine 1,000 columns and 1,000 rows. So it's going to be a very huge matrix. So the number of embeddings or the number of numbers that you have inside of this matrix is going to be really huge number. But each number is going to be very, very small. It's going to be somewhere like 0.001023, 0123. It's going to be very, very small number, but they are going to be in huge quantity. There will be many of them. So to visualize this, let's try to create an embedding of a very simple sentence. I'll go back to my Notion page. Okay. Again, let's copy this code. I'll put it here. So from transformers, I'm importing auto tokenizer again. This time I'm importing something called as auto model. And for the tokenizer and my model, I'm using this one, all mini LM L6 V2. This is given to us directly from the sentence transformers library. I can also use the sentence transformers library directly instead of using it from Hugging Face. But for simplicity's sake, let's just go with the transformers, which is Hugging Face. So this is the actual model that I'm going to use to create those embeddings. This is a very small model and I can run it locally as well. Let's take both of these sentences. This is an example sentence. Each sentence is converted. These are the two different strings that I've got in this array called sentences. I'll pass it to my tokenizer. This is my encoded input and I'll set it to the mean pooling. I'll get my embeddings. I'll normalize it, then I'll try to print it. Let's see how the embeddings will look like for both of these. Yeah, there you go. So let me put it in text editor. You can see there are two different embeddings here. The first one ends here and the second one starts here, but there are two of them in this. You can see that for such a simple sentence using this very, very basic encoder, we were able to create these embeddings. And if I adjust the parameters properly, I'll be able to create a much more bigger vector. What's the use? Why exactly are we converting these sentences into numbers? It's a very obvious answer. Machine learning models and any sort of AI model or any algorithm, any neural network cannot understand anything apart from numbers. All the predictions and everything happen based on numbers. So we need to somehow convert any information into numbers and then send it to the model. So what exactly are these numbers? How are they going to help us? Let's take this very simple example. We have three different rows here. Instead of, okay, let's take these three different rows. Let's try to plot them on a three-dimensional plane. X, Y, Z. Okay, so this is my three-dimensional plane. Now, if I try to plot all these different tokens on this plane, you can see similar words are going to be much more closer to each other and dissimilar words are going to be much more far away from each other. So laptop and mobile, they are both electronic devices. That's why they're going to be very close to each other. Man, king, and host will be very close to each other. At the same time, woman, queen, hostess, these are all different. Sorry, they're all very similar. So that's why they're going to be together, but they're not going to be in this or this or this. They'll be very closer to this one because all of these are proper nouns. They're all representing a particular person. So they are much more closer in their meaning and they occur much more frequently during sentences, and their contextual meaning is also very much similar. That's why they'll be very close to each other. So this is one advantage of creating embeddings. And in an ideal world, if you're able to crack the code somehow, and if you're able to figure out the exact embedding that can represent the word, then you can play with maths, where you can do king. You'll take the vector of king, which is like something like this. So this is one of the king vector. I'll take this. From this, I'll subtract the vector of man. I'm just putting some random values here. So king vector minus man vector, and I'll take the woman vector and I'll add it. So if I do the actual matrix calculation, so I'll take this matrix minus this one and I'll add this one to the result. I'll get one more final output here, this. And if I compare it properly, the actual word which is the equivalent of this particular matrix is queen. So which means I was able to perfectly capture the actual meaning behind all these words, because I'm able to just simply do the additions and subtraction and get the capture the actual meaning without losing any context. So in an ideal world, this will be a scenario, but so far actually we are pretty close to this one, to be honest, but not with this model that I've shown you in the notebook, not with this one, but the actual models that they are using in OpenAI, Claude, etc. They are way more powerful. Their embeddings are much more powerful and they capture a lot and lot of meaning. They are huge in size. Okay, so this is all about embedding. It's very, very essential to understand what exactly are these embeddings. So these are all the different big players in the game. So the reason why I've listed them down here is because creating the training data itself is a huge task. So if you have such a huge data, you need to tokenize it, you need to convert them into embeddings, then you're going to train your model. You'll face many number of challenges. I'll try to cover those challenges in a few seconds. But to do all of that training, you need a lot of money, first of all. And you will have to do a lot of preparation work for training the LLM model. So OpenAI, Google DeepMind, Meta, Anthropic, Microsoft, these are all different companies who have invested very heavily in AI world, and they are able to create all these LLM models by taking the data, converting everything into tokens, creating embeddings out of them, and then training the actual model. And these are some of the challenges that they usually face when creating a LLM model from scratch. First, of course, is going to be the massive hardware requirement. $1 million GPUs, okay? So training is going to take almost weeks of time. So you need to run your machines for at least a week, and you need really, really powerful GPUs, not just one or two, but you need a cluster of them. So you need lots and lots of power to train a LLM model. And also the energy consumption is going to be really huge because you'll be training them for almost 1.5 week, let's say, almost like 10 days, 10 to 12 days, and it is going to incur a lot of cost. and it's going to consume a lot of energy as well, because each GPU is going to drag more power, and it will require a lot of electricity, a lot of carbon emissions are also going to be produced. So this energy consumption is going to be very huge. That is why I believe it is for OpenAI itself. They have a data center where they train all of their LLM models, and the sound that you get from the GPUs, the fan sound, is so huge, it's almost equivalent to a jet ski sound. The sound that you hear during in the airports, it's that huge. So people are usually not allowed to go very near to that without wearing proper equipment and everything. So it's going to be really huge. That's how heavily the energy consumption is going to be for training these LLM models. Even to use them, you need a really powerful GPU. And also the data quality is going to play a very crucial role. If you take Claude, the only reason people prefer Claude is because the actual outputs that you're going to get out of Claude models are way better compared to ChatGPT or anything. But people don't use Claude for casual conversations like chit chat and everything. If you are serious about something, if you want a particular task that needs to be done, like writing a blog or writing a whole piece of code or a 500 lines piece of code, or if you want to fix n number of bugs, like 15, 16 bugs all at once in a 500 lines of code file, Claude is the way to go. Gemini or ChatGPT are not the best at doing that task. But if you want to have a very simple, casual conversation with a AI to have a fun chit chat, ChatGPT, of course. Even for your small day-to-day tasks, you can use ChatGPT. Or if you want a mix or something in between both of these, you can go with Gemini. So all these different AI models are trained on different types of data. They're all text data, of course, but Claude emphasizes more on blog contents or GitHub repos or code files. That is why their outputs are also going to be much more similar to that. Whereas ChatGPT, they have gathered data from all the different sources, so you can expect all sort of outputs. So in that way, the quality of the data will also affect your model performance heavily. In the next, I believe in the fifth or sixth lesson, we are going to cover something called as reasoning model versus chat model, where we are going to do a deep dive on how exactly the training data affects the model output quality. And finally, we have ethics as well. So on the last aspect, ethics, I need to tell you about Grok. So Grok is using Twitter data, of course. It is built by Twitter, or X, I should say, and it has a lot of rubbish. So Twitter, of course, we all know it has lots and lots of violent, sexual, harmful content, curse words. We have everything on Twitter. And because that same data was used for training Grok, if you ask Grok to talk in a very negative way, or if you ask it to write some curse words or anything, it cannot do any mistakes. It will definitely give you all those things. But if you ask the same thing for ChatGPT or Cloud or anything, they cannot even give those things, because the percentage of these bad things in the training data is very, very less. But in Grok, they have these curse words and etc. things in a much more bigger percentage. And that is why the ethics part has to be very carefully monitored. Even when we are fine tuning an LLM model, we should be very, very careful about what sort of data are we using for training that model. Because in once the training is done, the model is going to give out responses very similar to the training data. So if you're spending this much of money and this much of energy on training your model, we need to make sure that whatever data that we are sending is of good quality. So this is all about tokens and embeddings and how the training actually goes behind, and what are the different things or the different challenges that you face while training an LLM model. Next, we are going to cover what are chat models and what is reasoning model, the actual differences between both of these. See you in the next video. Thank you.